Hi and welcome to the video today, which continues our discussion on quadratic equations. So we're just going to analyze a few further concepts. So given that a quadratic equation ax squared plus bx plus c equals 0 has real roots, i.e. b squared minus 4ac is greater than or equal to 0. Now b squared minus 4ac is called the discriminant, very important. So if that's less than 0, it will not have real roots, it will have complex roots. It has to be strictly greater than or equal to 0 to have strictly real roots. So given that that's true, show that the sum of the roots, or SOR for short, is equal to minus b over a, and show that the product of the roots, POR for short, equals c over a. So I've got an example here, 2x squared minus 7x plus 6 equals 0. So we want to solve that for x. We want to show that the roots of that satisfy these two conditions. We want to show that the sum of the roots are equal to minus b over a and the product is equal to c over a. So we will check it to verify that. So once we've done it for an example, we're going to prove it in general. It's very easy to prove. Now, the discriminant for this example, b squared minus 4ac, is equal to 7 squared minus 4 times 2 times 6, which is 49 minus 48, which is 1. So it's greater than or equal to 0, so it has real roots. So it only just made it. But nevertheless, it's greater than or equal to 0. Okay, now what we're going to do is, there's various ways we can tackle this. We can factorize it, complete the square, use the formula. So let's try and factorize it, because that's the most sort of straightforward way, assuming that it's easy enough to factorize. So remember, for the factorization technique, we want two numbers that multiply together to give us AC. So that would be 12. And we want two numbers that add together to give us B. So that will be minus 7. So if you can find those two numbers pretty easily, then yes, factorization is the best way to proceed in this case. And yes, we have those two numbers. They are minus 3 and minus 4. Minus 3 minus 4 is minus 7, and minus 3 times minus 4 is 12. So now what we can do is we can split that up as so. So all I've done is split the minus 7x into minus 4x minus 3x. I've paired the minus 4x with the 2x squared, and I've paired the minus 3x with the 6. I've done that on purpose, so we can take a higher factor out on each side. So let's go ahead and factor this. And remember, once we have the first factor in the brackets here, we've already found the root. So one of the roots is 2. X equals 2 is a root, or R1 equals 2. So we can write that down again over here, and then a number will have to go here to satisfy this equation. So that's going to be minus 3. So that equals 0, and then combine them together, we get 2x minus 3 upon x minus 2 equals 0. And then our roots are x is equal to, well, if we set that equal to 0, what do we get? We get 2x equals 3, so x is equal to 3 over 2. And if we set that equal to 0, we get x equals 2. Okay, so let's verify that that satisfies this law or this principle. So one of the roots is 3 over 2 and the other root is 2. So let's add them together to get the sum of the roots. So therefore the sum of the roots is equal to 3 over 2 plus 2, which equals 7 over 2. Now, does that equal minus b over a? So we want the sum of the roots to be equal to minus b over a. And minus b over a is equal to, well, what's b? Well, b is minus 7, so minus b is 7, and a is 2, so minus b over a is 7 over 2. So yes, the sum of the roots does equal minus b over a in this case. Okay, and finally, let's check the product of the roots. So the product of the roots is equal to 3 over 2. I'll just show you the two roots again. 3 over 2 and 2. So the product of the roots is 3 over 2 times 2, which equals 3. And we want the product of the roots to be equal to c over a. Okay, so c over a equals, well, what's c? C is 6, a is 2, so that's 3. So that works as well. So I've just chosen a random example and I have proved that the sum of the roots is equal to minus b over a, product of the roots is equal to c over a. Okay, so now we're going to proceed and we're going to prove this in general. The general proof of this is not very difficult, so let's get into it. So consider the original equation again, ax squared plus bx plus c equals 0. If we divide through by a, we get x squared plus b over ax plus c over a equals 0. It will become apparent why I've done that in a minute. Now let's call our two roots r1 and r2. So the sum of the roots, SOR, is equal to r1 plus r2. The product of the roots, POR, equals r1, r2. r1 times r2, but we just write it as r1, r2. Okay? Now, when we factorize the original equation, we will end up with something like this. We will end up with x minus the first root times x minus the second root equals 0. And the reason for that is if we plug either of those roots into that expression, the answer will always be 0. Plug in r1, you get 0 times r1 minus r2. Plug in r2, you get r2 minus r1 times 0. So it's always going to be 0. One of them will be 0. One term inside one of the brackets will always be 0, regardless of which root you plug in. Now, let's expand that out. So we get x squared minus r1x minus r2x plus r1 r2 equals 0. So combine the x terms, x squared minus, all in a bracket, r1 plus r2x plus r1 r2 equals 0. And you'll notice we now have terms which contain the sum of the roots and the product of the roots. Yeah, we wanted r1 plus r2, we wanted r1 r2. We've got them now, okay? So now we can finish off the problem. So when we compare coefficients, we get minus, all in a bracket, r1 plus r2 is equal to b over a, because that's the coefficient of x. So that implies r1 plus r2 is equal to minus b over a. So that implies the sum of the roots is equal to minus b over a. So that's that proved. And then r1, r2, when we compare coefficients, well, that's just the constant term on the end. So that's equal to c over a. So that's a lot easier to prove. So that means the product of the roots is c over a. Okay? Now what you will find written in a lot of texts, you may come across this, is that the general form for a quadratic, when you write it in terms of SOR and POR, is that instead of writing it as ax squared plus bx plus c equals 0, you write it as x squared minus sum of the roots times x plus the product of the roots equals 0. So you'll see that written in a lot of places as well. Okay guys, so we've now proved that the sum of the roots is always minus b over a. The product of the roots is always c over a. Right, I'm now going to look at factorization in my next video slide. So we're going to be looking at the technique of factorization and why it works, why it always works. So it's connected to this. So it's connected to this principle here. Without these conditions, it wouldn't work. Okay, so it's all interlinked together. So one implies the other. So we're going to be looking at that. Okay, so thanks for watching, and I'll see you on the next video.